3 volts difference between the ground and neutral wires is a cause for concern. This voltage difference suggests a problem within the grounding system, potentially creating a safety hazard. There are several possible causes for this issue. Firstly, improper grounding can be the culprit. This happens when the grounding system isn't correctly installed or maintained, leading to a weak connection between the ground rod and the electrical panel. Secondly, ground loops may be the reason. Ground loops occur when multiple ground paths create a closed loop, causing voltage differences at various points in the grounding system. Thirdly, faulty equipment may be the issue. A defective uninterruptible power supply or other connected equipment could leak voltage onto the ground wire. The risks associated with a 3 volts difference between ground and neutral are significant. Electrical shock is a major concern. If the potential difference is high enough, anyone contacting both wires could experience an electrical shock. Equipment damage is another risk. The voltage difference can harm sensitive electronic equipment connected to the circuit. In extreme situations, a fire hazard may arise. The voltage difference can overheat electrical components, potentially leading to a fire. To address this issue, several actions are recommended. Firstly, hire a qualified electrician. A skilled electrician can investigate the grounding system and pinpoint the source of the 3 volts difference. Secondly, check bonding and grounding. Ensure that all equipment and junction boxes are correctly bonded to ground. Thirdly, inspect the uninterruptible power supply or opt for any faults or damage that might be causing the voltage leakage. Finally, once the source is identified, take steps to fix it. This might involve installing a new ground rod, breaking ground loops, or replacing faulty equipment. The presence of 3 volts between ground and neutral is a clear indicator that the grounding system isn't working as it should. It's vital to address this issue promptly to ensure safety and prevent potential damage. Ignoring the problem or assuming it's harmless is not advisable. Additional details to consider include the importance of a properly installed grounding system. This system is designed to provide a safe path for electrical current in the event of a fault. When the grounding system is compromised, it can lead to dangerous situations. Checking the ground rod is a crucial step. The ground rod should be securely installed and properly connected to the electrical panel. A loose or corroded ground rod can significantly reduce the effectiveness of the grounding system. Investigating the wiring is also important. Look for any loose connections, damaged wires, or other issues that could be contributing to the voltage difference. Consider the age of the electrical system. Older electrical systems may have deteriorated over time, leading to grounding problems. Upgrading the system may be necessary to ensure safety. Remember to always turn off the power before working on any electrical components. This will help prevent electrical shock and other injuries. Using appropriate safety equipment is also essential. Wear insulated gloves and eye protection when working with electrical systems. If you're not comfortable working with electricity, it's best to hire a qualified electrician. They have the knowledge and experience to safely diagnose and repair electrical problems. Documenting your findings is also a good practice. Keep a record of any issues you find, as well as any steps you take to resolve them. This can be helpful for future reference. Regular electrical inspections can help prevent grounding problems. Schedule regular inspections to identify and address any potential issues before they become serious. Consider using a ground fault circuit interrupter or GFCI outlets in areas where there is a risk of electrical shock. GFCI outlets are designed to quickly shut off power if they detect a ground fault. Educating yourself and others about electrical safety is crucial. The more people understand about electrical hazards, the better equipped they will be to prevent accidents. Keep electrical panels and equipment clean and free of dust and debris. Dust and debris can accumulate and create a fire hazard. Ensure that all electrical cords and cables are in good condition. Replace any cords or cables that are frayed or damaged. Avoid overloading electrical circuits. Overloading a circuit can cause it to overheat and potentially start a fire. If you're using extension cords, make sure they're properly rated for the appliances you're using. Using the wrong type of extension cord can be dangerous. Be aware of the signs of electrical problems. These signs may include flickering lights, burning smells, or buzzing sounds. If you notice any of these signs, investigate the issue immediately. If you're unsure about any aspect of electrical safety, consult with a qualified electrician. They can provide you with the information and guidance you need to stay safe. In summary, a 3 volts difference between ground and neutral is a significant issue that requires immediate attention. By understanding the possible causes, risks, and recommended actions, one can take steps to ensure electrical safety and prevent potential hazards. Remember to always prioritize safety and consult with qualified professionals when dealing with electrical problems. Following these guidelines will help maintain a safe electrical environment for everyone. Grounding is a critical safety measure in electrical systems, providing a low impedance path for fault currents to return to the source. This path helps to quickly trip circuit breakers or fuses, preventing electrical shocks and fires. A properly grounded system ensures that metallic parts of electrical equipment are at or near ground potential, minimizing the risk of electric shock if a fault occurs. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. Adhering to these requirements is essential for ensuring electrical safety. Bonding refers to connecting metallic parts of electrical equipment together to create a continuous electrical path to ground. This helps to equalize the potential between different parts of the equipment, reducing the risk of electric shock. Grounding electrodes, such as ground rods or ground plates, are used to connect the grounding system to the earth. These electrodes provide a path for fault currents to dissipate into the ground. The resistance of the grounding electrode is a critical factor in the effectiveness of the grounding system. A low-resistance grounding electrode ensures that fault currents can quickly flow to ground. Regular testing of the grounding system is recommended to ensure that it is functioning properly. Ground resistance testers can be used to measure the resistance of the grounding electrode. The size of the grounding conductors is also important. Grounding conductors must be sized according to the requirements of the National Electrical Code, or NEC, to ensure that they can safely carry fault currents. Improper grounding can lead to a variety of problems, including electrical shocks, equipment damage, and fires. It is essential to ensure that the grounding system is properly installed and maintained to prevent these problems. Grounding systems should be inspected regularly for signs of damage or corrosion. Damaged or corroded grounding components should be replaced immediately. Grounding systems should also be tested periodically to ensure that they are functioning properly. Ground resistance testing can identify potential problems with the grounding system before they become serious. The type of soil in which the grounding electrode is installed can affect its resistance. Sandy soil, for example, typically has a higher resistance than clay soil. The depth at which the grounding electrode is installed can also affect its resistance. Deeper installations typically result in lower resistance. The number of grounding electrodes used can also affect the overall resistance of the grounding system. Using multiple grounding electrodes can reduce the overall resistance of the system. The location of the grounding electrode is also important. The grounding electrode should be located as close as possible to the electrical panel. Grounding systems should be designed and installed by qualified electricians who are familiar with the requirements of the National Electrical Code, or NEC. Improperly installed grounding systems can be dangerous and may not provide adequate protection against electrical shocks and fires. Regular maintenance of the grounding system is essential for ensuring its continued effectiveness. This includes inspecting the grounding components for damage or corrosion, testing the ground resistance, and making any necessary repairs or replacements. Understanding the principles of grounding and bonding is essential for anyone who works with electrical systems. This knowledge can help to prevent electrical shocks, equipment damage, and fires. Consider attending a training course on grounding and bonding to learn more about these important topics. Staying up to date on the latest requirements of the National Electrical Code, or NEC, is also essential for ensuring electrical safety. The NEC is updated every 3 years, so it is important to stay informed of any changes. By following these guidelines, one can help to ensure that electrical systems are properly grounded and bonded, providing a safe and reliable source of power. Remember, electrical safety is everyone's responsibility. Always prioritize safety when working with electrical systems and consult with qualified professionals when necessary. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other electrical professional before making any changes to your electrical system. 3 volts between ground and neutral might seem insignificant, but it represents an abnormal condition. The ideal scenario is 0 volts, indicating a direct connection and equal potential. The 3 volts suggests current is flowing on the grounding conductor, which it should not under normal conditions. This current flow can be caused by several factors, including unbalanced loads, neutral ground connections at multiple points, or faulty equipment injecting current onto the ground. This small voltage can also become problematic for sensitive electronic equipment. Even a small voltage difference can cause noise or interference, affecting performance and potentially damaging components over time. Regarding troubleshooting, firstly verify the neutral ground bond at the service entrance. There should be only one neutral to ground bond at the main service panel. Multiple bonds can create ground loops. Secondly, check for unbalanced loads. An unbalanced load on a 3-phase system can cause current to flow on the neutral conductor and subsequently induce a voltage on the ground. Balance the loads as much as possible. Thirdly, inspect all equipment connected to the circuit, especially the uninterruptible power supply, or UPS. A faulty filter capacitor or other internal component can inject current onto the ground. Disconnect equipment one at a time to isolate the source. Fourthly, examine the grounding conductors. Ensure all grounding conductors are properly connected and sized appropriately according to the National Electrical Code, or NEC. Loose connections or undersized conductors can increase resistance and contribute to the voltage drop. Fifthly, test the ground rod. Ensure the ground rod is properly installed and has a low resistance to ground. A high resistance ground rod can limit the effectiveness of the grounding system. Remember that any electrical work should be performed by a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary safety precautions.